Hi, I'm Kevin. This is our group's presentation on the construction system of green roofs homes and the effect of this construction material on embodied and operational energy. We will begin with Brad, who will explain what green roofs are and the different materials used in their construction. Then JC will go over some of the different ways green roofs can help reduce the operational energy of a building. Lastly, EE will discuss embodied energy and how green roofs can help create a more environmentally friendly building, and touch on some of the shortcomings.
Green roofs are essentially a garden on the roof of a building. The plants used must have high tolerance to drought and small non-bulky root structures, as the growth medium is between 50 to 150 millimeters. Plants should be resistant to foraging and nesting from birds. The two main types of green roofs are extensive and intensive. Extensive green roofs have a shallow growth medium, between 3 and 6 inches, a lightweight requirement on the roof, have low organic matter in soil and limited plant options. They have low irrigation, nutrition and maintenance requirements. Plant options for extensive roofs are mainly sedums, which have thick leaves for water storage. Intensive green roofs have a deeper growth medium, 6 inches or more, have much heavier load on the roof, have much more organic matter in soil and plant options, including trees and shrubs. They have high nutrition, irrigation and maintenance requirements. The construction of the green roof is done in layers. The first layer is the waterproof membrane. Its function is to protect the building's roof from leaks. There are different types of waterproof membranes available. Some are produced as sheets from materials such as PVC. The sheet type is laid in place and joined by heat or chemical welding. Other types are applied as self-adhesive, either hot or cold liquid. The second layer is for protecting the waterproof membrane and roof structure from the plant roots. This thick layer will act as storage for water and nutrients for the plants. The third layer is for drainage. The main role is to remove water during and after rain. It's designed to retain a small portion of the stormwater without allowing excess water to pool on the roof. The water retained is then used by the plants. The fourth layer is for filtration. It separates the growth medium from the drainage layer. Its purpose is to prevent the growth medium from washing away and clogging the building's drainage system, while keeping the nutrients available to the plants. This filter layer is usually made from geotextiles such as fleece or other woven materials. The top layer is the growth medium. This layer is the soil that the plants grow in. The depth of the medium depends on the type of green roof used. For extensive green roofs, the medium should be 6 inches or less, and for intensive, 6 inches or more. The soil type selected needs to have good water and nutrient retention and resist frost and erosion.
Green roofs can noticeably reduce the operational energy of a home by acting as a great thermal barrier. This is due to the garden's ability to deflect and absorb the sun's rays. Bare roofs soak up the sun's heat and transfer that to the interior, raising cooling costs. A high leaf area index, which is the measurement of the amount of leaves in a square meter, can improve the potential energy savings provided by the green roof. Retrofitted houses with a moderate amount of insulation to begin with can expect to save up to 15% on operational costs. Expectations of energy savings can be high due to the promised savings percentages that are seen in multiple reports, claiming up to 70%. This is because the greatest reductions were in homes with green roofs that had no insulation before. It is important to investigate how these reported energy reductions were produced, as misinformation could lead to under-insulated homes. Green roofs alone cannot insulate a house. It has been shown that the depth of the substrate nor any other factor are as effective as insulation. If the aim of adopting a green roof is to reduce the home's environmental impact, then cellulose insulation would be a great substitute for glass fiber bats, as it is mostly shredded recycled newspaper. Green roofs have long been claimed to reduce urban heat islands, which are created through the expansion of cityscapes that trap and retain heat, increasing the surface temperature at pedestrian levels. This, in turn, also increases the cooling costs of large city structures. There is, however, sufficient data to back up the claim that green roofs can reduce temperatures of cities, with temperatures in concentrations of green-roofed buildings being reduced up to 3 degrees. Trees with dense foliage have the most impactful effect, but reducing the amount of exposed building surface is also important. One caveat to the reductions in temperature may be in the form of evapotranspiration, which is a natural process of plants that transfers moisture of soils to the air. The increased humidity can make the air feel hotter than it actually is.
Another form of energy that green roofs impact is embodied energy. This represents initial energy or CO2 consumed in the production of materials and constructing the building, as well as the energy required to operate and maintain the building. This is an important aspect to consider as these costs are ongoing. That is, a building's embodied energy is continuously increasing as long as the building is in use. Green roofs can also be used to take advantage of a natural process to reduce the building embodied energy, while reducing air pollution within city centers at the same time. Given that embodied energy is a measurement of amount of energy or CO2, green roofs have a negative effect on this measurement as plants have ability to convert CO2 into fresh oxygen. As air blows against the plants, they take in tiny CO2 particles and use excess energy to convert these particles into clean air. Studies have reported a reduction of PM10 of up to 9.1 grams per square meter annually, which is a measure of particle matter that is small enough to enter the lungs. Increasing the surface area for the pollutants to blow against is key to increasing its conversion. So, long dense patches of grasses are recommended. There are also reports that suggest vegetation at ground level may have a greater impact due to their proximity to pollution producers such as cars. Comparing to the traditional roof construction, there are more specific design and materials should be applied on green roof construction. For instance, the soil layer is necessary because plant relies on soil to grow. This is common sense that the soil and plants will absorb much water, so the higher quality requirement on drainage system is needed. Roof pitch is also needed to pay attention because a smoother roof pitch is easier for plant cultivation. For the specific roof design, the higher roof load capacity is needed. Although the purpose of water membrane is for green roof building, and it is environment-friendly construction, some of the materials used in is not environment in some degree. There are three options to create a waterproof. Built-up roof is one of these three, which is a layer of asphalt. It is true that asphalt could provide a good performance on drainage, but there are some negative influences should be attention to. Firstly, asphalt is a petroleum-based product which is a non-renewable resource. This is harmful for environment and sustainable development. Secondly, as the product is converted to the asphalt, significant quantities of harmful gases are released into the atmosphere. Furthermore, the polluted water with asphalt residue might flow down drainage network into lake and ocean.
In conclusion, green roofs are roof gardens constructed of nature and man-made materials, layered in a method to enable greenery to grow and thrive while maintaining the integrity of building through sufficient drainage and waterproofing. In addition to being eye-pleasing, green roofs play a functional role in reducing operational and embodied energy of buildings. It reduces operational energy by acting as a form of insulation by deflecting the sun's rays and thereby reducing the energy required to cool the building. We should not, however, overestimate the insulation effect of green roofs as they cannot act as an insulation purely on their own, and therefore are the best implemented as supplement to traditional insulation. In addition to reduce operational energy of building itself, green roofs also reduce operational energy of cityscape by reducing the temperature of surrounding urban heat islands, contributing to overall environmental friendliness of the city. Green roofs also impact on embodied energy of the building. By converting carbon dioxide into oxygen, green roofs contribute energy into ecosystem, thereby negating or offsetting the entitled energy consumed in constructing the building. One negative aspect to note is that the waterproof membrane required in construction of green roofs is not environmentally friendly. Having said that, all the benefits of green roofs make them a very attractive option compared to other traditional roofs, as long as a cost-benefit analysis is performed beforehand.